Hello everyone, in this video I'm going to go over a useful question from the last US Open competition. It's called Acowdemia. So essentially, just summarize the problem. Bessie wrote research papers, and each paper has C citations. So there's an index to measure the success level of a cow of index H. So what does index H do, and how does it work? So according to the problem, the H index is the largest number H, such that the researcher has at least H paper each with at least H citations. So we want H paper and each paper with H citations. And so if we have like if I have like 2 and 1000, the H level will be 2 because there are 2 papers and they both have at least 2 citations. Yeah. So let's say our papers have 13044 citations. So let's plot them like graphically. They will look like this. But it is kind of hard to find the H level. So we sort it. We can sort it by like increasing order or decreasing order. So here I sort it by decreasing order. And we can easily identify H level by trying to fit a square with H as its side length into the graph. So here we can know our H level is 3 by fitting a square with H side length into the graph. So the blue square is our H square. Okay. However, Bessie is a smart cow, and she doesn't want to have a low H index, so she wants to maximize her H index. And she will write K paper to maximize her H index. Each paper can have can cite L research. Each survey can cite L research papers. So let's take it graphically. So she is trying to make up the area to form a bigger H square. So if she make up, let's use a different color then. So if she use her survey, the green color, to make up the thing like this, the total research papers like this, then she will obtain H square of 4, H index of 4, looking like this. However, she doesn't have unlimited surveys or amount of surveys she can cite on. Amount of citations she can put on each survey. So essentially, K and L limits her ambitious plan. To maximize the amount of H index she can obtain, we're just trying to add the citations to form as big of H square as possible. And we can binary search it. So we can binary search the H index. So we have like H level. It can be any number, and we check if that number will work or not. And how do we check it? We have 2 standards. The first standard is all difference we need to make up. The diff we need to make up has to be smaller than. That should say each difference we need to make up. So like each bar we need to make up to the H to meet the H heights. So let's call it each diff. Each diff has to be smaller or equal to K, because we can now set the same source multiple times in a single survey. So the increment of each bar has to be smaller or equal to k. The second thing we need to make sure is the sum of the total area of the thing we need to make up has to be smaller than k times l. That's the total amount of citation we can make from our survey. And with if both of them are satisfied, then we know such h-index is workable and it's possible. So we can just binary search the h-index and find the largest one. Okay, let's implement our code. Include bits std C++ using namespace let's put the variables here because we want to access them in the check function, and they can just be easier if we are making them global. Okay, so let's make them x, y, oh actually that's bad naming, and kl. So you're taking the inputs, create a vector of publications, vector int papers. Okay, let's make it 1e5 plus 1. So for int item smaller than I plus plus. Input papers as index, paper I index I. Okay. For doing that, we'll just sort our vector. Actually, let's just resize it. Paper it stores them in decreasing order. Okay, so let's put a comparator inside, and that's it. Now we just gotta implement our binary search. Oops. Low minus, and low has to be smaller than high. So int mid equals to low plus low with high minus low. Am I doing it right? Am I doing it right? Oh yeah, I think we do that too. Okay, so we check it. If mid works, then we set low to mid. Otherwise, high equals to mid minus 1. And after doing this, we obtain our answer as low. Still low, and yeah. Okay, let's go to our main part of our code, which is the checker function. Check int mid int sum. So we're calculating the total area. Let's just make it total make up area just to 0. So we loop through indexes. Hold on. Yeah, I think it's good. I smaller than plus plus. Because our index is start from 0, so we are our last research paper we're gonna check is mid minus 1. Okay, so if If our paper at IS index is smaller than mid, then we gotta make it up. So sum to tot make up plus equals to mid minus paper I. Also we gotta check if ABS mid minus paper is bigger than K or not. If it's bigger, then we know it's impossible to like, because we cannot set the same twice on the same survey, so it is false. Okay. And in the end, we just check if our total area is bigger than L times K or not. Oops. So if it's bigger than, it's false. So if it's smaller or equal to L times K, then it's true. Okay, let's try to, oops, wrong code. If it's smaller than, oh, is this wrong? Wait, let me compile again. Paper, oh, papers. Yeah, next time I'm just gonna name it paper. Oh, bruh. Okay. So first one, 441, 100, 113. Okay, the first one works. Let's try the second one. 414. 100, 1. So 2. Okay, both of them work. That's our code in the grader. So I'm not actually live solving this. So yeah, I already solved it. So I'm just trying to like recode it. Okay, so we got a few test cases wrong, but yeah. Wait, what if it's because we didn't use long line? It's probably that. Okay, let's run our code again. I hope it works. Okay, as you can see, all the test cases passes, so thank you for watching. I will consider to post more useful content in this channel, so thank you. So bye.